Okay, so quickly tell me if I'm audible or invisible or not. Okay, if I'm audible and visible both, so I'll just start with the video. But anyways, I can't see how many people have joined though. Code. Okay, someone needs code, huh? So I'll just do one thing. I'll just quickly share the link on Discord and then start with the video. Okay, just quickly share the link on Discord and just start with the video as soon as it's posted on Discord. Okay. I don't know what the heck is wrong with my throat. I think I'm having a very sore throat at this moment, so that is the reason I can't put my voice till the maximum. So yeah, you have to tolerate with it. Okay, so let's start with the video. I think. Okay, put this over here only, or more like over here. This good proportion, and then I'll just put this over here. So I think everything is perfectly visible and audible, right, in front of you guys. Guys, quickly tell me if I'm audible and visible, okay? Because I can see that there are 3 people watching this right now. So if I'm audible and visible, just write in the live chat that yeah, you're audible and visible. Okay, nothing more than that. It's that simple. Okay, nothing more than that. It's that. Yeah. So from my end, I'm perfectly audible as well as visible. Okay. Discord. Anyways, I have solved all the 4 problems also. Okay, so yeah, I'll be explaining all the 4 problems. Okay, so I have put the link on Discord. So let's start with the first question, the maximum product question. Okay, you're given an integer array ARR of length n, and also given two integers L, R, and L is lesser than equal to R. So you have to choose one element from the subarray L to R, both are inclusive, and another element from the remaining part of the array, and you have to maximize the product of them. Okay, so what you have to do basically. Now let's say you have an array. Okay, let's say you have an array. Now I'll just change the color. So till this, that is till L to R, you can find out whatever is the maximum, right? And for the remaining part, you can also find out what is the maximum. For the remaining part also, you can find out what is the maximum, and you can multiply them. Okay, let's say this is M1 and this is M2. So from one point of view, it may seem to you that this is the best approach. Okay, it may seem to you that this is the best approach. But what if I told you that this is not the answer? Because it was already given in the question that it can be till minus 10 to the power 9 also. So let's say if I am having both the numbers as negative, so that negative into negative becomes positive. So I am basically more focused on the fact that whichever is going to give me the product, I have to just maximize the product. So that doesn't mean that both of them has to be maximized. Okay. So I can also find out the minimum from here and the minimum from here and check which is going to give me a better answer, multiplying these two elements or multiplying these two elements. So is this clear with you guys? So why do we do it? Why are so less people right now watching this? I don't know. Why are so less people right now watching? So anyways, you don't need to focus on that. So basically, yeah. So why do we do the minimum thing? It is because let's say I've got minus 10 to the power 9 and 1. Okay, in the green part. And in the red part, I have also got minus 10 to the power 9 and 1. So if I find the maximum element, so that is 1 into 1, it is going to give me 1. But if I find the minimum element, that is going to give me minus gets cancelled out and it gives me 10 to the power 18. Right? So is this clear? Is this part clear? I think this part is clear with you guys. Okay. So if this is okay, now 3 people are watching this. So if this is clear, I'll just go with the poll. So just tell me this is clear, then I'll move on to B. Otherwise, it's a no. Okay. Just quickly respond to the poll. So based on that, I'll just go on with the remaining video. Anyways, I think I will also show you. Okay, someone voted no. Why no, brother? Which part is not clear? Just write in the live chat which part is not clear. So see, what we do is, in this code, I'm taking M1, M2, M3, M4, as I've told you in the explanation. And then for this part, that is from 0 to L minus 1, and from R to N, that is the remaining part of the array. That is the green part. Okay, and this is the red part. So the red part, the maximum is M2 and the minimum is M4. And for the green part, the maximum is M1 and minimum is M3. So we have to find whichever is maximum, M1 into M2 or M3 into M4. So I have done a lot of permutation and combinations. I'll just end the poll, because I think that if you find that this is, you're not understanding it, you can just write in the live chat. Okay, the live chat is already there for you. Okay, so where was I though? Yeah, I have checked all the permutation and combination for M1 and M2, but you don't need to check them. Okay, you don't need to check them individually. You can also go for this. You can either multiply M1 with M2 or M3 with M4. Okay, so if you do this, then also it's a valid thing. I should have directly submitted the code so that, okay, I think I put an extra, okay, I've forgotten to put the comma actually. Now I think if I submit it, it's going to be perfect. Its correct output is -2. Your code's output is -9. It's either M1, M2. Its correct output is -2. Yeah. So from that 4 to 6, 4, 5, 6, 4 to 6, I'm choosing either the maximum element and maximum element. That is M1 and M2 are the maximum element and maximum element. And M3 and M4 are the minimum and minimum element. And then I'm returning. So the minimum element over here, it is 3, 4, 5, 6. It's -1, -2, -9. The minimum into the minimum into the max. Okay, so it may also happen that the minimum into the maximum is also satisfying. Okay, so you have to find all the permutations. Okay, do you get it? You have to find all the permutations. That is M1 into M2, M3 into M2, or M1 into M4, and M3 into M4. Okay, you have to find all the possible permutations. So what do we mean by that? All the possible permutations. So it may happen that, so there are various test cases. Okay, for now, at this moment, maybe I'm not coming up with a better test case, but it may happen that this is negative and this is positive. So you have to find out all the possibilities. Okay, and based on that, you have to find out which is going to give you the maximum answer. So I hope this is clear with you guys. So I'll move on to the next next problem. B, that is boundary sum of matrix. You're given an integer matrix of size n into n. you have to find the sum of each level boundary. That is, let's say we have this kind of matrix. So I'll just put it in over here. Okay. So what we do is, for the blue line, you can see that we are going for the outer boundary. Okay. And for the orange line, we are going for the second layer boundary. So we have to find out the sum of all the layers of boundaries. Okay. What is basically needed in that question. Anyways, people who are watching this, it's a mild request that please do like the video and subscribe my channel. Okay. Now this is how the level traversal works. Okay. Now how can we find out which element is in which level? Okay. So you can notice one thing, that for the first level, this element is 0, 0, this is 0, 1, and this is 0, something. Okay, this is 0, n minus 1. Okay, then this is 1, n minus 1, and we go on till n minus 1, n minus 1. Which means that either the row or the column, if it is at the boundary, then it's at level 0. If it is at a distance of 1 from the boundary, then it's a level 1. Or rather, it's over here, we were given a 1 best indexing, so it was told us that the level are like 1, 2, 3, 4, but for our convenience, we are just taking 0, 1, 2, 3, something like that. Okay. Now, how can we find out a level? So if the first element is 0, or the last element is 0, okay, the last element is 0, or the first element is n minus 1, or the last element is n minus 1. In that case, we can say directly that it's a border element, right? And similarly, we can find out at which border every element is. How can we find out? We can just subtract n minus 1 from them. We can just subtract n minus 1 from the last element, or keep the last element as it is, or take the first element, or subtract n minus 1 from the first element and check at which position it is. Okay. So I think it will be better if you look at the code directly. Why is answer is the size of answer is this? I'll explain it later on. Okay. So for all the elements, I'm going to check what is minimum. I is minimum, or j is minimum, or n minus 1 minus I is minimum, or n minus 1 minus j is minimum. That is, it is going to tell me the distance from the border. Okay, this is the distance from the border. And then specified on that basis, we are going to make answer of that plus equal to matrix of this. Now, what is the number? Okay, what is the number of what is the level? What is the maximum level that we can reach? So let's say if I'm having a matrix of size n into n, so I can divide the matrix into two parts. And how many are over here and over here? It is going to be our level, right? There is going to be a level, maximum level. But let's say if the matrix was of odd length, like this. It's 1, 2, 3, 4, 5. So if it was odd length, so the middle of it will be over here. But what is the depth? This is at depth 1. This is at depth 2. And this is at depth 3. So basically, it is at depth of n by 2 plus n mod 2. Okay, more like the ceil function. So based on that, then we go on to code the whole thing and we find the answer directly. And then we return it. Okay. So let's move on to the next problem. Maximize your health. So this is a problem which I think is kind of interesting, kind of like a good problem. I'm perfectly audible, right? Yeah, I'm perfectly audible. So you're given two types of drinks, A and B. which can boost your health. Okay, so your there are n drink glasses of each type in separate lines. You can drink at most X glasses of drink A and Y glasses of drink B. But there is also another condition that you have to start drinking from left to right from each row. If you have started to drink a B type glass, then you can't drink a A type glass after that. And for every index, you can either choose A type of glass or B type of glass, or you can choose none of them. When can you choose A type of glass? If there is no B type of glass before it, because that was given over here. And when can you choose B type of glass? If B type of choosing B type of glass is not a big deal. Okay, so let's visualize this. Okay, first of all, let's visualize this. So before starting the whole solution, and let me tell you that this is a DP kind of problem. So till a specific position, okay, till a specific position. In the previous part, we can take drinks of type A, and in the next part, we can take drinks of type B. Now remember one thing, some of them we can ignore. Okay, some of them we can ignore also. Some of them we can ignore. But remember one thing, the ignorance should be in such a manner that you can take at most X number of drink A and at most Y number of drink B. That was also given in the question. Okay, at most Y glass and at most X glass. So based on that, you have to find a DP. Okay, that is, I'm going to take at most X drinks from here to here of type A and at most Y drinks of type B from here to here. And then I can add them up. What is going to give me a maximum value? Okay, but how can we perform it? How can we make the value of DP? Okay, so it is very evident that always we have to choose the maximum, the X most maximum values of A from here. Since we can choose at most X values, so we'll choose the X most maximum values. And remember one thing, if from the X most maximum values there is some negative value, so we are going to ignore it, because a negative value is not going to improve the sum. It is going to just depreciate it. Okay, so basically what you can do, initially you can make all the negative values 0. Okay, because you are not going to consider the negative values, just make it 0 for your better implementation. And then take two priority queues. One priority queue will be priority queue of A. Okay, and other priority queue will be priority queue of AA. What is that? I'll just tell you later on. And there is a priority queue of B, and also a priority queue, just ignore the line, of BB. So what does A means? A means the elements which are in the left side of that point, but we are not considering them. Okay, this we are not considering. But AA means the elements that we are considering. BB means the elements we are considering, and B means the elements we are not considering. So what is the size of PQ of BB and what is the size of PQ of AA? The size should be the maximum size of PQ of AA and should be X, and the maximum size of PQ of BB should be Y. Because we can take at most X and Y drinks, right? Now using a DP, what we can do is we can start from here to here to calculate DP of B. Okay. And to calculate DP of A, we can do the reverse thing. Start from here and go until over here. DP of A. Okay. Now, based on this, okay, so anyways, people who are new to this channel, I'll just tell you that just please subscribe my channel and like this video, okay? And apart from these facts, so we can do this, okay? We can do it by using these two methods. So the question is, whenever we are inserting it, so if the size of this is lesser than X, the size of this is lesser than X, then we can say directly that whatever the element is we are encountering, we are going to put it into PQ of A. But if it is like already X, that is we have got X elements, then we have to find out that which position, in which priority queue are we going to put the element A of I? Okay, how can we find it? So if the minimum element over here, PQAA, it is greater than this element, so this element is not going to improve the sum, right? It's not going to improve the sum, so we are going to put this element over here. But if it is the opposite thing, then we are going to put this element over here, and whichever is the minimum element of this, then we are going to put it over here. So is the flow chart, like, I think the flow chart is okay for you, right? And similarly, what we do for this, we are also going to do the same thing for B of I also. Okay, the same thing we do for B of I. So B of I either gets directly put into it either gets directly put into over here, or it gets put into over here, and one element from here gets put into over here. Okay, so let's go with a dry run so that everything becomes easier for you to understand. So 5 minus 1 minus 3 minus 2 1. Okay, 5 minus 1 minus 3 minus 2, what I forgot what it was. Minus 1 minus 3 minus 2 1. Minus 1 minus 3 minus 2 1. Okay, and what is the next position? It is minus 2 1 5 4 2. Minus 2 1 5 4 2. Minus 2 1, sorry, minus 2 1 5 4 2. Now tell me what the DP should look like. So I'll just put a little bit of space over here. Okay, now I think it's properly like understandable for you guys. Now whenever we are going for A, okay, whenever we are going for A, so let's say we have got PQ of A and PQ of AA. So what is PQ of A looking like, and what will PQ of AA look like? So we know that the value of X was 2. Okay, so maximum 2 elements can be in PQ of AA. And remember one thing, whenever there is a minus 1, we make it 0. Okay, we make it 0. Or whenever there is a negative number, we make it 0. Because we ignore the negative values. Okay. So first of all, when we encounter 5, we put it over here and make the sum. So this is not the sum, let's say DP. Okay, or let's say sum only, sum of A or sum of 1, we make it as 5. So what is the first element of DP? It is 5. Then we encounter 0, so we put the 0 over here and we add 0 to this, so that remains 5 only. So again we make it 5. This is DP of A. Then again we encounter a 0, but at this moment we have to find out whether the 0 is going to be inserted over here or over here, right? It is better to insert the 0 over here. So if the 0 is inserted over here, it is not going to affect the sum. Then again we have a 0, it gets inserted over here. Now we have a 1. Okay, now we have a 1. So where this 1 is going to be inserted? This 1 is going to be inserted over here. Why? Because the smallest element, that is 0, it is lesser than 1. Okay, it is lesser than 1. So what happens? This element, okay, now I'm using a different color. This element gets cancelled out and it becomes 5 minus 0. Okay, and 1, like from here this element gets cancelled out and it moves on to over here 0. Okay, and the 1 gets put in this case and this becomes plus 1. So what is the sum 1 now? It's 6. Okay, so it was 5 5 5 till all the positions except the last position where it was 6. Okay, Now if we go on to do for B, okay, now for PQ of B and BB, okay, so what will B look like and what will BB look like? We are more concerned about that right now. So I'll just make it a little bit smaller. Now see, it was initially 0, so I'm putting 0 over here, and what is sum? It is equal to 0. Okay, then what we had? Then we had what to say? Then we had 1, right? So 1 gets put over here. Now we add 1 to this sum. Okay, so initially it was 0, then it become 1. Then we have 5 over here. Now 5 will be put over here, over here. Now what is the minimum element over here? It is 0. So we are going to rewrite this 0 as 5. So make it minus 0 and plus 5. And remember one thing, we put the 0 over here. Okay. So what is the value right now? The value right now is nothing but 6. Now if you notice one thing, till now this PQ of A and this PQ of B, these were not needed actually, right? These were not needed. We just needed PQ of A and PQ of BB. But just in order to make you understand it better, so I just used it. Otherwise it won't be needed. Okay. Because we are just going to find the X most elements in that range. Okay. Okay, sorry, I made a mistake. Sorry. I made a mistake in the calculation of PQ of B actually. Because we know that A was traversing from left to right, but B will be from right to left, right? So it is initially 2. So S of 2 is initially 2. And we have 2 over here. Then 4 comes. So now it becomes 6. So this is now 6. So the previous element is 6. Now 5 comes. So this gets rewritten as 5. So 3 gets added to it. That is 9. Okay. So now it is 9. And after that there is 1. So nothing will be changed over here, and that is 0. So nothing will be changed over here. So it remains 9 and 9 only. Okay. Now look at this. Okay. Now since we have got dp of A and dp of B, so we can have 6 or 9, or we can have 5 plus 9, 5 plus 9, right? Because if like the partition is going to tell us that it is dp of I, dp A of I minus 1 plus dp B of I, right? Because dp B of I is this position and dp A of I minus 1 is this position, because this is where the partition is, right? So for every partition we can find the value. So it can be either 6 or 9. So what is maximum from that? 9 is maximum. It can be 5 plus 9, that is 14. It can also be this 5 plus this 9. Okay, this 5 plus this 9. It can be this 5 plus 6, this 5 plus 2, this. Okay, so this is what how the diagonal relationship looks like for both of them. This kind of diagonal relationship. And what is the maximum? The 14 is the maximum. Okay, so the answer is 14. Okay, so let's move on to the next question. Longest increasing path in a tree. Now this question is a very simple question, but a more of data structure implemented question. So we have to find the longest path starting from any node, and if we traverse till that, from that position to some other node, all the values of that positions are in a strictly increasing pattern. Okay, so let's say if you're traversing from 6 to 1 3, so the values are 1 2 3 and 4, which is a strictly increasing thing, and this is the maximum length that can have a strictly increasing path. I mean the longest path of strictly increasing things, okay, values. And we have to just find the longest path only. That is what we are more interested about. Okay. Anyways, people just new to this channel, please do subscribe my channel and like this video, okay? 6213, 6213, 6213, 6213. Okay. Now since we are going for 6213, so what we can do is we can start from any base that we feel like. We can start from any root. So if we are starting from 1, then if we are performing a DFS, okay, that is I'm going, let's say I'm performing a DFS, so I'm going from here to here, then here to here, right? But we know one thing, that we are going to perform a DFS only. We are going to perform a DFS only if the next element is strictly greater than that element, right? Otherwise, we don't perform the DFS. So that is how we can optimize the whole approach. You get it? So from 3 to 2, it is not strictly increasing, but from 3 to 4, it is strictly increasing. So what is the value of this? It is going to be, the maximum length of this is going to be 2 for node 1. Okay. Now if we are going till, now if we have, like now we are going to check for 2. Okay. So we can go from 2 to 6, but we can't go from 2 to 2, or neither can we go from 2 to 1, because that is going to give us a wrong DFS. But we can also go from 2 to 3 also. So in either cases, the maximum length is 2. Okay. Now what we can do is, now we are going to check for 3. So this 3, we can't go from any place. From 4, we can't have a DFS. So it's going to be 1 only. And then we are going for check for 4. And for 4 also, there is no other position to go. So this is also 1. Now if we are starting from 5, then we can have a DFS. No, we can't have a DFS. Okay, because both of them are same and it has to be strictly increasing. So in this case also it is 1. Now comes the last condition, that is this one. So we can have a DFS over here, right? But once we have a DFS over here, we have seen that we have already made the values for this, right? We have already got the value for that. But remember one thing which I forgot to mention you, that when we were going for this, YouTube isn't giving notification. Yeah, I also think so, because I don't see that many people have joined this. I don't know what the heck is wrong with YouTube. But anyways, after I post it, I think there will be people who are going to watch it. Okay. So yeah, this is not getting that interactive, but it's okay. But remember one thing, whenever we can perform a DFS like this, so we are going to add this plus 1, that is 3. Okay. So this won't be 2, it will be 3. Okay. This will be 1. This will be 1 and 1. These are ones only. But this thing, we can go from here to here. So it's going to be 3 plus 1. That is 4. So what is the maximum value? So this was 1. Okay, I forgot to mention. So what is the maximum value for all of them? 4 is the maximum value. So 4 is the answer. Right? Now let's get into the code. So you'll understand what we have done. So for the time being, I'll just put this comments section over here. Now see, I have performed a DFS. That is the DFS I was telling you. So if I have already computed the DFS, that is dp of I, then I can directly return dp of I. Okay. But if I have not computed it, so I have to compute what is the maximum length that I can get from that position. What is the maximum length that I can get from that position? I have to find out all the neighbors. And if the value of a neighbor is greater than value of I told you that we are going to perform only DFS if the next element is strictly greater than that. So if it is greater, so max of length is equal to maximum of maximum length, comma 1 plus DFS of that. That is that position, whatever the DFS was for that position, plus 1. Okay, plus 1. So we are basically using memoization, that is dp of this thing, to make it much more efficient. Okay, and then dp of I is equal to maximum length, and we can return that. Okay. So I'm having adjacency arrays, and this is normally basic thing. I'm having a DP of all are going to be -1, and answer is going to be initially 1 because at least one element can be there. The maximum length of path can be 1. Okay, because that node only, so it can be 1. Then for all the elements, for all the nodes, I am performing a DFS, and whichever is going to give me a maximum value, I'm going to keep it, and then I print the answer. So I'm assuming that this is okay with you guys. Like the whole thing is okay with you guys because the contest was not that difficult. What I feel is, and so let's move on to directly with the rating of the problems, and then I'll just end the video because I have to like end the video. Okay. So just let's read the problems quickly. There were in total 4 problems, right? You know my rating system, right? How I rate problems. So this is easy, this is medium, this is hard, and this is impossible. Okay. Now, if you're talking about the first question was maximum product. It was um, just because of the fact that it's not completely maximum, so I'll just rate it somewhat between easy and medium. The very next question was boundary sum of matrix. You just needed some observations, so I'll also rate this. I'll rate this as medium only, okay, because you needed a little bit of logic. And for the next problem, maximize your health. This was a good problem. So I'll not rate it hard actually, since it was kind of DP also. So I'll just rate it over here. And D will be also rated. I think D I will rate over here, medium. Or rather not medium because it needed DFS and DFS is not that easy concept. So I'll rate it over here. So none of the problems according to me was in this range. Okay, from hard to impossible. None of them were in this range. So that is my rating for the contest. So I hope that satisfies everyone. Okay. Since there are not much people right now, and I did the third one using priority queue. Yeah, same thing. You had to use priority queue only. So since there is no much response, like not much people watching this, so I'll just end the live stream. Okay. Bye guys. Radhe Radhe.